when trusses are designed, we want to be able to identify some of the members that carry no load. So let's take a look. We'll assume that this truss is pin connected at all these joints. It's supported here by a ball, and let's say a load is being applied here, let's say with a load F, and we'll label this as point A, B, C, D, E, and F. If I were to do a joint analysis of point A or pin A, I would get the following. That pin at A experiences a force due to member AB perhaps pulling on it. So this will be force AB. And that pin will also experience a force due to member AF perhaps pulling on it. We'll use the coordinate system as such. So this is my free body diagram of pin A. With that free body diagram, I should be able to apply my equations of equilibrium. So therefore I have FAB, there's no other X force, so that's equal to 0. And sum of the forces in the Y, that's FAY is equal to 0. And sum of the moment about point A is equal to 0. That's trivial. So what I've shown you is that members AB and AF actually have no loading on them. So here's a general rule that you can use, and you should memorize this. General rule to identify zero force members. And this rule only works if you have two members that are connected. So if only two non-collinear members form a truss, form a truss joint, and no external load or support reaction is applied at the joint, the two members must be zero force members. Then the two members must be zero force members. Okay, that's a lot to memorize, but it's easy once you see some examples. So let's move on to examples. So let's take a look at this. So here we have a truss where a force is being applied. It's supported by a pin here at, let's call this A, let's call this B. It's supported by a roller. We'll call this C, D, E, and F. We have to try to look for two members that are connected to one another, and only two. So we see that member BC is connected to member CD by a pin. There are no forces being applied at this joint. Therefore, member FCD is equal to 0 and FBC is equal to 0. Therefore, BC and CD are zero force members. Let's take a look at another problem. So here we have a truss assembly. It's connected by a pin here, another pin here as well. We'll call this A, B, C, and D. We try to look for two members that are connected to one another. Here at this joint, there's actually three members, so we're not interested in joint C. But at D, we have two members that are connected to one another. However, a force is being applied at that joint, so force in AD does not equal to 0, neither does a force in CD. Therefore, AD and CD are not zero force members. So here's another rule. It turns out that if three members are connected to one another, one of them is actually a zero force member. So let's look at the criteria for that though. So here we have a truss. It's connected by a pin here and it's on a roller. It's pin connected here and it's pin connected at all these joints as well. That's point A, B, C, and D. And there's a force that's applied at D. So if we have two members that are connected and they're collinear, and a third member is connected to that collinear set, then this third member is actually a zero force member. So the rule is if three members form a truss, if three members form a truss joint, so here are the three members, and two of the members are collinear, this third member is a zero force. This third member is a zero force member. Then the third member is a zero force member. Provided that there are no external forces or support reactions at this joint. Provided no external force or support reaction has a component that acts along this member. Whenever you start analyzing trusses, you really want to identify members that are zero force members. So in this problem, what we're going to do is try to practice finding three force members and finding that third member that is a zero force member. So we first need to find collinear members. So we have CD and DE, that's collinear. So we look at member DF. There are no forces acting at that joint or along here. Therefore, member DF is a zero force member. We know that GF and FE are collinear, but it has actually two other members attached to it. So we're not going to look at that joint, nor do we even consider that CF even has a potential to be a zero force member. We note that HG and GF are collinear and it has this third member. There are no forces acting on it, therefore it is a zero force member. Same thing with joint H. We know that AH and GF are collinear, but it actually has two other members attached to it. So we can't say that this is a zero force member, nor can we say that this is a zero force member. So we go to members AB and BC. They are collinear, and it has this third member. However, this 2 kilonewton is being applied at that joint. Therefore, BH is not a zero force member. So BH is not a zero force member.